folks. Welcome to another Lunch and Learn. My name is Kevin Holbrook. For those of you I have not met, I've been with CADimensions about 16 years now. One of the things that I've noticed in the past 3 or 4 years is quite a few changes to Weldment Cutlass and the ability to manufacture or create a correct cut list that might be part of its own drawing or part of a much bigger bill of materials. So today I want to kind of break down the options related to Weldment Cut lists so that you can make better decisions about organizing and creating these cut lists for use downstream and exporting and so on. The process that we're going to use today to review the cut list, we kind of broke this down into a few different sections here. And all of this revolves around creating an accurate cut list, again, for the bill of materials or for the welded frame that you might be creating. So I broke it down into 6 sections. The first one is how we might organize the cut list. And let me preface this a little bit by saying that we're not going to talk about creating the physical weldment today. We're focused specifically on the cut list after the fact and organizing it. So if you're uncomfortable with weldments in general, this won't fulfill that need. This is more on the cut list side. So we're going to talk about organization, how to keep them up to date and what options are related to that. The sorting, when I say sorting, I'm talking about some of the automation that's built into that to organize and sort by like members. We're going to talk about naming conventions, how it gets that information and what we can do to help that. I want to talk about properties related to the cut list members individually and as a whole. And then I want to finish it off with a bunch of miscellaneous tools that I couldn't come up with a single title for, so I just called it miscellaneous tools. So let's get started with how we organize a cut list. Now, the way I've kind of approached today is I have a completed weldment. This happens to be a crossover frame for a structure. This has multiple different methodologies within it. You're talking bent tube type structural members as well as standard framework and also other objects like the treads on the stairs that will be part of this as well. When I look at the organization piece of Weldment Cut list, the first thing we talk about is just the order in which things are listed in the cut list itself. If you look here, the cut list when it's created just gives some generic numbers to the organization based upon how it was recognized within the system. It organizes them. Really, it has something to do logically by the order in which things were created, but also the like members. So the first thing that you may want to do is reorganize some of the information. In my particular case, I have a series of treads that show up as the second item. I have the top flat surface, which is also another item, and I'd really like those to be at the bottom. One of the ways to do that is just right here in the cut list is to be able to drag and reorder the cut list items. I want you to notice that the cut list item does not change name. So you do have the ability to reorganize here. Another place that we go that will provide us a lot more information about the organization is the properties window. Now, if you've never accessed the properties window for weldments, you can right click on any item and turn on the properties window by right clicking on that item. And the reason I bring that up here is cut list item 2 is the treads that we're working with, and I want to reorganize it. You'll notice that I can grab that from the tree here and I can drag it down. It's not as obvious that it would move, but it physically does also move in here. So if you happen to be in this window and you want to do some reorganization, you can certainly do that. Now, part of reorganization is to take cut list items that you might not want listed in a cut list table and exclude them. And it's pretty obvious here how that's done. If I wanted these particular items excluded, I can make the selection here and just select exclude from cut list, and they will no longer be listed in the cut list table. You'll notice that even in here, if I can get this to expand out a little more, it says excluded from cut list. So it does give you some indication that it's been excluded from that cut list. Another way to do this is also directly by right-clicking on the cut list item. You can start to exclude those individually. Now, I often get asked, well, what if I've created some geometry in a welded frame? One second. Looks like we got some audio issues here. Just want to make sure everyone has audio. If you have any issues with audio, can you please raise your hand in the GoToWebinar window? I've got one question posted with somebody having audio issues. Just want to make sure it isn't across the board. Does not look like anyone else is having issues. So I'm going to continue. I apologize, Fred. It might be something on your end. Just turn up your speakers or something to that effect. So back to what we were working on here. The exclusion is just the right click. We talked about that. But sometimes you create features that create members that you want excluded for one reason or another. And there's actually a way to do that that's kind of interesting. In this particular case, here I have, the first structural member feature that created 3 members. And at this point, I don't want these listed in the cut list. How do I exclude those without going up here to each individual item and excluding? And you can see that there's actually a mirrored version on the other side. How do I stop those all from showing up on the cut list? Now, this is a little trick. You may want to write this one down. If you right-click on the feature that created the cut list item, there's an option called Make Weld Bead. Now, it isn't obvious that you would use this for this, but making something a weld bead is assuming that you're going to exclude anything that feature created from the Weldment Cut list. So if I select Make Weld Bead, okay, these items, okay, if I update my cut list here, and we'll talk about updating in just a moment, you can see that several of these structural members no longer exist within a folder for that. So it is the ability to exclude those from being organized by the system, and you can actually reverse that by right-clicking on the structural member and making it a non-weld bead. And you'll see here that we do have the ability to bring everything back exactly where it was. So there are some limitations to that tool, and you'll see that as we move along. But if the feature was a parametric feature like a revolve, like an extrude, some of those features do not allow for that. So if you look in the help, there's a pretty good list of what does and doesn't work. But it's a nice little trick there to deal with excluding different items. So that's organization. Drag, drop, exclude from list, maybe make weld bead. That allows us to at least get things in the order that we want them to show. Next thing we need to talk about is how do we keep these things up to date. Okay, so let's jump back to our cut list. And I want to talk about how we even know something is up to date. So I'm just going to make a quick little change in here. See if I can get to the dimension here. It doesn't want to pop up. Let me get another one here. Try to get to a sketch here that I can modify. Yeah, let's edit the sketch in here. All right. Yeah, nothing wants to modify at this point. Let's see if I can get, there you go. So all I did was edit the sketch. I'm trying to trick the system into thinking that there's been something done. If you look at the cut list itself, there's actually a couple different symbols that you'll see as a cut list icon to let you know whether the cut list is up to date or whether it needs to be updated. The symbol that you're seeing now with what looks like a rebuild series of arrows on it lets you know that an update is required with this cut list. To update, we have options on the right click. Now, there's 3 of them that are important to how we're working with weldments today. The first one, create cut lists automatically. What this does is as soon as you create a weldment and you save and create members, this will start to create that initial cut list. Okay, so the first time as you get going and adding members, it's going to create the cut list. The ones below that allow you to determine when and how often it's going to update the list. Update automatically. Every time you make a change to a member, it's going to update the list and reorganize that list so that they are completely up to date. And then just the update function, which I'm going to do in this case, is you telling the software to update at that particular time. Now, there's been some changes to these 3 functions over the years. So here's what I would recommend. I would check your templates that you use for welded frame and see which ones of these are turned on by default. Now, SolidWorks made a decision if your templates were created before 2015, create cut lists automatically is turned on, and update automatically is also, I believe, turned on. Best way to do this is to open up the templates. If you find that the values here are incorrect, what you'll want to do is make a change and save the template. If your templates were created in 16 and 17, they should just have it just like you see here, create cut lists automatically with the other 2 turned off. Now, I think it warrants some discussion on as to why this update automatically is not as useful as you would think it would be. I also want to show you where in the tools options, document properties, that this stuff exists. Under document properties, weldments, and this is where you go in your template, there's an option in here to automatically create cut lists and automatically update cut lists. You'll notice that there is a little disclaimer here that may affect performance if you have automatic update. Now I'm just going to kick that on for this particular case. And if we look, you can see it just kicks it on here. It's a toggle. It works in the options. It works here. But here's an example of where update automatically maybe isn't as useful depending on how you work things in your tree here. So for example, I have right now 2 structural members, a right and left hand version. They're the same length, essentially the same structural member, but I'm going to treat one of them a little differently. I want it listed in the cut list differently. We're going to do some secondary machining to accommodate something. So what I can do, and we've talked a little bit about reorganization, is just drag and drop that solid body to the root of the cut list. Okay. Notice what it said is it was going to cancel the automatic cut list generation. Now, that's great because now in 2017 it at least has some understanding of what that means. When you start to organize things that are alike in different folders, in previous releases, the software doesn't really understand what you're trying to do. You can see this structural member is now removed from this cut list item. If I happen to have had on the automatic cut list creation, you'll see that it automatically puts it back into the same folder. So for those of you on 2017, that automatic option will be recognized as something the software should turn off if you've done some reorganization. But for those of you on 16, 15, and previously, if you've for some reason started to do some reorganization and wanted to add that to a separate folder or separate cut list item like this, put it in its separate as a separate body, create cut list item, and then what happens if you create cut list automatically, notice this is item 21, you'll see, okay, please delete the existing. So these are all fail-safes that were added in 2017 in order to be able to do this. Because I manually added the cut list item, it can't reorganize it. So I have to go down here, delete the cut list item, okay, and then go ahead and create cut list automatically, which will allow me to bring that back in. So that's kind of a word of caution for those of you who are maybe using older releases. But keep in mind the symbology. I showed you the one for update. If the cut list is up to date, this is what the symbol will look like. It's kind of hard to see. I know there's a structural member, but some other symbol over the top of that as well. So mentioned the templates. I would definitely, if any of these strike a chord, go in and check your templates just to make sure you're getting things the way you would expect them to. Okay, so that's how we keep them up to date. Now I want to talk a little bit about sorting. Sorting is the process that happens when the software decides to do an update. How does it figure out what members are exactly the same? And this is very important in the software because this is a way that you can accidentally make some mistakes within the software. So if I look at this, the sorting typically is done by members of the same shape and the same length, but there's a caveat to that. So what I've done in this case, just to make an example, is I've created a structural profile that's exact as this frame member that we had on the bottom here. That's 69.51 inches. Let me create this structural member the same length using a different method. 69.51. When I say different method, I'm not using the Weldment features to create this. And you'll see here that if we look at our list, that it does add a new cut list item to the list, even though it's exactly the same as these two structural members on the underside. Okay. The reality is this is the same as those, and I'd rather have those in the same folder. So this is where the sorting options come into play. If you right-click on the cut list, there is an option in here for cut list sorting options. Okay. The very first option in there, collect identical bodies, ignores the method that was used to create the geometry. So even though I extruded this member versus using the welded frame features, by turning this on, I can go ahead and ensure that that particular item ends up in the proper folder, which is cut list item 3. Unless you do that, these other members that you create in different ways will not get automatically sorted the way you would expect. Now here's another example of sorting. I'm just going to create a simple change to one of these members here, and I'm just going to put a little cut through just that member. Now as soon as I do that, you'll notice that this particular member now is in its own folder. So the software with its sorting options has decided that that particular member is unique compared to the member on the complete opposite side of the welded frame. But in reality, I might machine that thing after the fact or drill a hole or whatever it happens to be. I still want those treated as two of exactly the same members. So the cut list sorting options, if I go back in there, allow us to select faces or features to exclude. So when it's trying to collect and look at how bodies are identical, it's using all the faces and features that belong to them. Well, one of the things that I can do is tell the software to exclude that new cut that I just created. In other words, ignore that. And when I do that, the software will now treat this as the same as the other side. Okay, so the sorting options play a big role in how the software is going to assist you in sorting what's there. Now, let's look at a little different example just so we can clear this up. For those of you who are not aware of how to do this, what I've done is created sub-weldments. Sub-weldments is just a function of the Weldment tool. It's very simple to create. All you do is select the members you want as a sub-weldment, right-click and say Create. You can also drag and drop into a sub-weldment once it's created. So what I did for the railings is I created them as sub-weldments. By creating them as sub-weldments, what this does is it organizes the folder structure and it creates its own cut list items below the sub-weldment. So this is almost like having these in their own part. It will organize them separately. Now I've done this for both sides of the frame. So these are treated as completely separate sub-weldments, one side and the other side. The reason I wanted to pull this up is just so that you understand when we do the sorting and we have sub-weldments, it doesn't sort between the sub-weldments. Just because there's two members in each of these that are exactly the same, if I can mouse over which ones here. So these four, it's not going to put them in the same folder because they are part of a sub-weldment, almost a sub-assembly like we would typically see in an assembly of SolidWorks. So there is a little bit of a difference here when it comes to sub-weldments. And I'm going to use this example a little bit more in just a moment. Now back to our crossover frame here for a second. You'll notice here that when I look at the tree, I'm still dealing with a series of generic names for the naming conventions. And the next topic that we want to talk about is naming. Now I can certainly come in here and using the Windows slow click, I can call this, whatever I want, Rail A, start to give some identifiers to it. It will continue to give the quantity next to it. And that's okay. One of the things that we're able to do in the last few releases has to do with how the system is going to name these folders automatically. Now, if I jump back to the options that we were in earlier, under Document Properties, Weldments, there's an option in here to rename cut list folders with the description property value. Okay, so let's turn that on for a moment and say OK. And you'll notice that all of my cut list items now changed name. Okay. Now, how do we know, all but the two folders here, how do we know where this information come from? Well, I took you earlier to the Properties window where I right-click on one of the items and go to Properties. If you select Properties, you'll notice that several of these cut list summary folders have descriptions. That's where this information is coming from. So if I go down here and find what I'm looking for, any of these, you can see that the description does exist. Now I did this way for a particular reason because I manually renamed Rail A. When you do the automatic naming of the cut list item, it doesn't overwrite the value if you've manually modified the value. Okay, so because I called it Rail A, it's not going to use the description, even though in Rail A there is a completely different description here. So you would have to manually rename that after the fact. Okay, but it will use that value. For instance, if I go to another one here and just give it some other value here. you notice it automatically renames that because it was never overwritten by the user. Now for items like this that don't have a description, I can go to the properties window and it's cut list item 4. If I wanted to, I can start to add properties, and that happens to feed into our next topic, which is properties. But before I get off the naming for a second here, I want to talk about when these naming changes occurred. The automatic naming was added in 2016. So any templates that you've created after 2016 will have the automatic naming already turned on by default. If your templates are old and you've kind of worked them through the years, those will have that automatic naming off. You will have to go in and open up those templates and set that property in order for them to work. Now in the case of our cut list item, it's very simple to put your information in here, and I'll call this my deck lid, and once I put that in there, it will rename the cut list item for me. So anything that does not have a description, go to the properties and start to add the properties in there. Now that warrants a much deeper conversation on properties. This cut list window that we see has several areas to it. The first one is just the summary, which contains all the cut list item. That's kind of where we were doing the exclude and so on earlier. But it also lists, as you click through here, which properties exist in each. The properties come from a list. And when I come down here to this P125, if I want to add another property, I pull down the menu here, and you can see there's a list of standard properties for a welded frame. Now that list is nothing more than a text file that's part of the installation directory. If you want to adjust this list so it has the properties that are important to you, just go up here to the edit list function and you can add items to it. Okay. The one thing this doesn't do, let's say I'll just give myself a property in here. And one thing it doesn't do is when you add it to the list, it doesn't add it to each one. Okay, you can see in here, I would have to come in here, add the property to be able to apply it manually. So I often get asked, well, how do I add a property to all the Weldment Cut list folders at one time? Now this is something that most people have not stumbled upon, but watch this. If I go to the Weldment feature and I right click on it and go to properties. Now you can see this is essentially the same window but with no Weldment Cut list items in here. What I can do is come in here, add the property Kevin property, and I'll say this is a test. I'm going to put a value in there that it should have by default. And when I say OK to this, the software is going to put that property in each Weldment Cut list item. So you can see the full list. As soon as I click on one of these, they all have the Kevin property with this as a test applied to it. So if you've ever wanted to apply, at least get the property listed in every cut list item, that's a great way to do it. You may still have to modify the value. Not a lot of properties will have the exact same value or expression, but this is a way to get that in each and every one of those. Now there are two other tabs at the top of the cut list properties. One is the property summary, which shows you everything, every property that you have. You can select on it and it tells you which members have that property and what their value is. Now the great thing about this, as I mentioned, this gives you one spot to go in and modify. You can give different values for the different items here very easily. Now the third tab is the Cutlass Table. This is a preview of the table itself. The nice thing about this table when it comes to properties is that this is kind of a preview of what you can expect to get if you were to place this on a drawing. So this also gives you the opportunity to resize the column widths. So if you see that the properties are very small, you can start to organize this. And these column widths are actually stored in the file. So when you place the weldment into the drawing, it will automatically use those widths to help you out. Okay, so some very, very nice tools in here to do that. Now I want to get into my final step, and I've skipped a few here, is just the miscellaneous tools that are part of weldments. And I want to start out just reminding everyone that the materials is something that the Weldment Cut list sorts on. So I have those 3 structural members that were created in here. If I decide I want to apply a material to one of those, let's say a cast alloy, as soon as I apply the material and it realizes that it's different than the other 2, you'll notice that this now becomes its own cut list item. So the Weldment Cut lists are material aware. Another aspect of Weldment Cut lists that's important to remember has to do with the configurations. By default, there are 2 configurations that get created for a weldment. The default as machined and the default as welded. The as welded is a derived configuration. In other words, it takes all of its properties from the parent. So if any of the members change length or so on, it will update. The difference is the as welded gives you an opportunity to add things like weld beads, remove holes that maybe are added after the fact, versus the as machined, which will have any secondary operations or other features that you might have. Now, the reason I bring this up is twofold. One, the cut list is always related to the as welded configuration. That's the one that it's developed from. So I want you to be aware of that. If there's something that exists in the as machined but does not exist in the as welded, potentially it may not exist in the cut list. So everything is based on as welded. Now, back to our options for a moment. If we go back to those options, document properties, weldments, we can set up whether or not the software even creates an as welded versus as machined. Now, some of you may not be utilizing machined versus welded, and if you're not, it's probably creating some confusion at times within the drawing, within the model, which one should I be looking at. If that's the case, you can turn off the create derived configurations and the automatic naming. These are just description strings, which as machined and as welded, that get assigned automatically to those. Those now can be turned off within the software. Now I will leave mine on, but turn that off. Other miscellaneous items that you may not be aware of. One of them is bounding box for welded frame. Now, if you're not familiar with a bounding box, it's the ability to put a 3-dimensional box around a structural member to give the overall dimensions and to capture those overall dimensions. Now, you can do that by going to the cut list folder. Now, you got to be careful because I almost did that. I right-clicked on the item. You got to right-click on the cut list folder, create bounding box. Now, what it does, it creates a 3D sketch, and you can see in here that represents the box that will fully encompass that particular part. Now, keep in mind that you do have the ability to edit the bounding box, even change its angle and so on if you wanted to use a different box to make the connection. Now, where does this show its head in welded frame? If you go to the properties, the software automatically extracts the box dimensions to a property that can be utilized elsewhere. So 3" by 3", and here's the length and the widths of them. Okay, so everything is listed here: length, width, height, and actually volume of the bounding box. So it's something that we use a lot for sheet metal parts, but maybe not as much for weldments, but is absolutely available. I'm going to jump back to the one with sub-weldments for a moment. There is certainly an opportunity to want to take these frames like I created here and create their own part from them. Maybe create your own cut lists because you're going to create a drawing of just this sub-weldment. And I want to make it clear how that happens. Now, this can happen for individual members, individual cut list items, but if I were to go to this sub-weldment folder, there's going to be an option to insert into new part. Now, this also works for the save body command and the insert part command, which I'll show in just a moment. If I select insert into new part, it knows all the members that are related to that sub-weldment, but there's specifically an option that's important to this. There is the ability to propagate all the cut list properties, all that information we were just dealing with, to this new file. All we have to do is give it a file name. I'll just call this rail, and when I do so, it's going to transfer all that information over to the new part with the cut list items. Okay, you can see the sub-weldment exists, each item exists. If I go to the properties, okay, there's only one quantity because it's an individual sub-weldment in this case, but you can see all the properties exist, and they all came over from the original document. Okay, so it's important to see that. Now, I've been asked in the past to also do things like, and I believe the person who asked this is online, ability to take things like a lifting lug and drop this into a welded frame and have the properties exist. So how would you do that? Take a part that exists in another file and bring it in. The function is just insert part. Now, I've created just a simple lifting lug, a 60-degree pig ear lifting lug, typical for ISO containers. If I open this up, notice the options during insert part also include custom properties and cut list properties. Now, I'm just going to pop this in here. It asked me to change the units because they're different units, but I want you to see that now this item gets listed in the cut list tree. All I have to do is update the tree here. It should create its own folder. I know I need to update because of the refresh. Go ahead and do my update. And if I go to the properties of this item, you'll notice there is a description. It says it's linked to the parent part. So it got its description from the original part, which is the one I inserted. So if properties do exist outside of the part or inside the part that you've placed into the assembly, it will exist here as well. Okay. Okay, so let me go ahead and place this into an assembly. I'm going to put the weldment into another level assembly. Let's go ahead and save it to my desktop here, and let's create a drawing of it. So I want to talk a little bit about a few details on the drawing before we close here today. Oh, it's going to close for me, but that's okay. You can recover from that. All right. I want to talk specifically about the bill of material functionality at the drawing level when you create the cut list. I think the cut list table is pretty self-explanatory. Let's see if my assembly exists here. Yeah. Must have crashed before that. So let's make the assembly. When I place this in the assembly and I save this thing out, see if it'll save this time. All right. Now let's make a drawing. Some people are confused by the result of the bill of material when there is a structural frame within it. Okay, now keep in mind I didn't detail out just with the cut list. I've placed this into an upper level assembly, so it's going to look a little different. I'm going to insert a bill of materials to my drawing. Now what happens when a bill of materials contains a welded frame? You may be confused by the result that you get. You can see it says, oh, I got one crossover frame, and here's the amount of pipe I have, 1 1/4 inch pipe, and the total length, and then the 3 by 3 by 1/4 inch members and the total length. But the reality is what you're seeing here is not what we had on the cut list. Okay. Now, if I look at this, you can see, it kind of gives me an idea. Some of these things don't have properties. If I go back to my crossover frame, I had 46 total items, but much more listed there. So how do I get my drawing to reflect that? Well, if you want to itemize the crossover frame and its members, you have to use an option under Bill of Materials called Detailed Cut List. When you do a detailed cut list, each item is listed below the subassembly, or in this case a welded frame, and it will be accurate to the cut list as you would expect. Now, if all of these items needed to be up a level, you can also dissolve the subassembly or the welded frame, which will promote all of those members up a level as their own item numbers. So there is a little bit of nuance there that will help you a little bit. I want to talk a little bit about the precision of the tables. Now, some think that the precision of the length is dictated in the part level. Mostly, you're going to change your document properties and your precision on your dimensions here, or I'm sorry, on the tables here, so that we can update the length to the number of significant figures that you desire. That's done at the drawing level inside of SolidWorks. And the last thing that I just wanted to note before we close has to do with cut lists and the number of cut lists that you can have per sheet. Right now, SolidWorks does only allow one single cut list per sheet. So if you've attempted to place a second cut list, you'll see that won't allow to happen. All right. So I want to thank you for coming today. Hopefully we got through everything pretty easily. We're a little bit over time. This was a little bit of an advanced session. I kind of assumed that most of you had experience with weldments, so I was trying to show you all the ins and outs, the areas that maybe aren't as easy to understand. It looks like we do have a few questions. We'll go ahead and answer those, and then we'll close up. So these sorting options replace the need to suppress machining features in the as-welded configuration. Yes, unless you're using the machining features, you typically have that in the as machined. By suppressing them in the as welded, you're basically making those bodies exactly the same, and that's what allows it to automatically resort. This does replace that. It does make it easier depending on the number of bodies that you have, or the number of features that you need to suppress or remove. In this case, you're still have to select the faces or the features that the software should ignore when determining whether two bodies are exactly the same. So absolutely you can explore that, and that should help us keep that organized. So that was the one question I have. This session will be recorded, so you will be able to access this on our YouTube channel in just a few days. Hope you had a good time, and we'll see you at the next one. Take care.
Don't forget to check us out on YouTube, Twitter, Facebook, and our blog for more great content by clicking on the links in the description below.